Imagine you are buying a used car. You walk around it, kick the tires, and check the paint. It looks perfect. Shiny, no dents, great color. You buy it, drive it off the lot, and 10 kilometers down the road, the engine explodes. Why? Because you only looked at the outside. You didn't check the oil pressure, the temperature gauge, or the mechanics. In the world of marine conservation, we are doing the exact same thing. We draw lines on a map, call them marine protected areas, sanctuaries, no-take zones, and the like. When the populations and numbers remain stable, we assume everything inside is fine. But underneath, the animals may not be doing okay. Their blood chemistry is out of whack, stress hormones surging, and they're struggling. Welcome to Episode 4 of Athletes of the Reef podcast. I'm your host, Alex Morgan.
It is great to be back, Alex. And you are absolutely right. We are treating our oceans like a car without a dashboard. And frankly, as a conservationist and a physiologist, it is terrifying.
Today, we are taking a slight detour from raw shark physiology to talk about something that dictates whether those sharks survive or not. Policy. Specifically, a paper the Rummer Lab team published just in 2025 in the Journal of Experimental Biology titled Harnessing Physiological Research for Smarter Environmental Policy.
Yes, this is a very important piece of work. It was led by Dr. Alexia Dubuque, who is a brilliant researcher. Not only did she earn her PhD at JCU, but she also worked with my team as a postdoctoral fellow and mentored several students. She led this perspective piece along with a fantastic team, including many of my current and former students. Indeed, this piece is a call to action.
So, Jodie, let's start with the basics. What is the difference between how we usually do conservation, ecology, and what you are proposing here, which is conservation physiology?
When we think of ecology, one aspect that may come to mind is numbers, taking a census. Yeah, so ecologists can count the animals, the number of species. Are there more? Are there fewer? It is population level data. If the numbers drop, you know you have a problem. But here is the catch. By the time the numbers drop, it is often too late for ecosystem health.
Right. Counting dead fish doesn't save them.
Exactly. Conservation physiology involves looking under the hood or bonnet of the car, so to speak. We examine the mechanism. We check the animal's heart rate, their oxygen uptake rate, their stress hormones. We look for the sublethal effects. The animal is still alive, yes, but is it thriving? Is it feeding? Is it growing? Can it reproduce? Or is it barely hanging on because the water is, for example, 1 degree too warm? Physiology gives us the why, and more importantly, physiology can also give us the when before the collapse happens.
So if we have this user manual for the fish, for example, if we know exactly what temperature makes a shark stop reproducing, or what oxygen level makes a grouper stop feeding, why aren't policymakers using these data? Why isn't every law based on this?
If only it were that simple. This paper highlights exactly that frustration. There is a massive disconnect, a scale mismatch. We scientists measure things on an individual fish in a tank. in some cases in the controlled environment of our laboratories, or at least with a pre-organized experimental design in the field. A policymaker needs to make a law for an entire reef for the next 10 years. Translating "this fish got stressed at 29 degrees" into something like "we need to shut down this fishery" is incredibly difficult.
Is it just a translation issue? Or is it a language barrier?
It is both. We found that policymakers and scientists have completely different definitions of success. For a researcher, success is getting a paper published in a high impact journal. We want precision. We want to say there is a 95% probability that. But a policymaker, they want a solution. They want certainty. They need to answer to voters today, not in 5 years when our study finally makes it through peer review.
The paper mentions something called conceptual impact versus direct impact. It sounded a bit like procrastination. What's that about?
It is what we call knowledge creep. It is slow. Sometimes our research doesn't change a law immediately. Instead, it slowly seeps into the consciousness of the policymakers. They become aware of an issue, like ocean acidification, gradually. It is valuable, but it is slow. And the climate crisis, it is not slow. We do not have time for a creep. We need a sprint.
Let's talk about where this has actually worked. Because the paper isn't just a list of complaints, right? You highlight some success stories.
Indeed. One of the best examples, in my opinion, at least, involves the Pacific salmon. This is a classic case where physiology met policy. Researchers looked at the aerobic scope of the salmon.
Aerobic scope. That's basically the difference between their resting metabolism and their maximum exertion, right? Like how much energy they have in the tank.
Exactly. It is the spare energy they have to swim up a river. The research showed that when the water gets too warm, that aerobic scope collapses. They physically cannot make the journey. Because of this physiological data, managers can now predict, based on water temperature, whether the salmon will survive the migration. If it is too hot, they close the fishery to let the fish pass without the added stress of being caught. That is physiology directly dictating the law.
That makes total sense. If it's too hot to run a marathon, you cancel the race. You don't just hope the runners make it.
Precisely. So, another beautiful example from the paper comes from Nunavut, Canada. It involved the Greenland halibut. So the existing management lines on the map, the zones where people could fish, were based on old assumptions. But the local Indigenous communities, the traditional knowledge holders, knew the fish were moving differently.
So the locals were saying, hey, the fish aren't where you think they are.
Yes. And scientists used biotelemetry, so they were tracking the fish and validated exactly what the locals were saying. They combined that physiological tracking data with the traditional knowledge and presented it to the Nunavut Wildlife Management Board. And guess what? They moved the boundary lines. That is what we call knowledge co-production.
Knowledge co-production. That sounds like a buzzword, Dr. Rummer.
It sounds like one, but it is the solution. Usually, scientists do the work in a bubble, write a paper, and then throw it over the fence to policymakers, hoping someone reads it. Co-production means you bring the policymakers and the traditional custodians and all of the relevant stakeholders, for that matter, into the room before you even start the experiment. You ask them, "What do you need to know?" Instead of telling them, "Here is what I found."
That seems obvious. Why aren't we doing that?
Because the system isn't built for it. Academic institutions, well, they can be slow beasts. We get promoted for writing papers, not for having coffee with a senator. The paper explicitly calls out this lack of infrastructure. There is often no funding for that relationship building. It takes time to build trust with Indigenous communities or government bodies, and grant cycles are short.
I want to go back to the stressors you mentioned. We talk a lot about temperature on this show. Hot water creates wolverine baby sharks, but burns through their energy. What else are policymakers missing?
One major one that Alexia highlighted in our paper is UV radiation. We worry about sunburn, right? But we rarely put UV radiation into our climate models for fish. But clear water combined with ozone depletion and shallow habitats means these animals are getting blasted. It damages their DNA, inhibits photosynthesis in the corals, and increases disease susceptibility. It is a silent killer. And it interacts with temperature. A hot fish is stressed. A hot, sunburned fish is probably going to be dead.
And yet, I've never seen a UV safe zone on a marine map.
Exactly. Another one is pollution thresholds. We use these terms like LD50, lethal dose 50%, which means the amount of toxin that kills half the population. That seems like a terrible metric for conservation, or at best, it still sounds pretty rough.
Yeah, half of them died is not a great success rate.
We need to look at NOEC, no observed effect concentration. The Deepwater Horizon oil spill taught us this. The oil didn't kill all the fish immediately, but it caused developmental abnormalities in their hearts. They couldn't swim as fast. They couldn't escape predators. Physiological research revealed that damage. If scientists had only counted dead fish on the first day, we would have thought, oh, it's not so bad.
So, the paper is a perspective piece. It's an argument. What is the solution? What do Dr. Dubuque and your team want to happen?
Well, it is a call to action for three groups. First, researchers. We need to get out of the lab. We need training and communication. You can't just throw graphs at a politician. You need to tell a story. Second, institutions. Universities need to value policy work. Give us time to do it. Don't punish a young scientist for spending a month working with a government agency instead of writing another paper.
And the third group?
The policymakers themselves, they need to create space for us. They need to ask for the evidence. In the UK, they have something called the Universities Policy Engagement Network. In Australia, we have Science Meets Parliament. We need more of that. We need to be in the room where it happens.
It sounds like we need to treat the planet less like a political debate and more like a patient in critical condition.
That is it. The athletes of the reef are tough, but they have their physiological limits. We can measure those limits. We just need the people in power to read the charts.
Dr. Jodie Rummer, always a pleasure. If people want to support this work or read the paper, where should they go?
They can find the paper open access in the Journal of Experimental Biology. They can find us, our team, at rummerlab.com. We have a donation page there that helps support our students, those who are doing this critical work. And remember, healthy sharks equal healthy reefs.
Thanks for listening to Athletes of the Reef. Next time, we'll get back in the water. Until then, stay curious.